8.4, continuing. Now we're going to go to example 4. And so this is dx over 1 plus x squared squared. Okay, the 1 plus x squared, that looks back at the triangles and looks like it's going to be one of those tangent ones. So I'm thinking about this triangle. I don't know if I want to write it like this or not. The 1 plus x squared makes us think that x should equal tangent of theta, and dx would be secant squared of theta, d theta. And so if I do that, inside here I'm getting, let's just take the denominator, the 1 plus x squared squared would be 1 plus tangent squared of theta squared over 1 plus tangent squared is secant squared. So this turns into secant to the 4th of theta. If I substitute in then, my dx is secant squared of theta d theta. That whole mess on the bottom turned into secant to the 4th of theta, which then reduces to 1 over secant squared, turning into cosine squared. And then we have to use the half angle on that, which turns it into 1 plus cosine, 2 theta over 2, which turns into integrating 1/2 and integrating 1/2 cosine 2 theta, or pulling the half out, either way. So I end up with 1/2 theta plus, now, the integral of cosine is the sine of 2 theta, but the derivative is 2, so I need a 1/2 in front. But there's already a 1/2 in front, so now there's a 1/4. Okay, so now I have to go back to x's. So let me draw that triangle. We said this is 1, this is x, this is theta, this is the square root of 1 plus x squared. Okay, so I need the sine of 2 theta. Well, the first thing I have to do to this answer is fix the sine of 2 theta to be 2 sine theta cosine theta. So this is going to be turned into, let's do the 1/2 theta first. If I do the theta, I could say that the tangent of theta is x. So if I'm trying to solve for theta, that would be arctan of x. So in my 1/2 theta, that's going to be 1/2 arctan of x. I'm going to change this other piece. I'm going to work it, I think, down the page and then go back up there. That 1/4 sine of 2 theta, we're going to turn it into 1/4 and then 2 sine theta cosine theta, double angle identity for sine of 2 theta, which then would become 1/2 sine theta cosine theta. So back up here to my 1/2 arctan of x, I would have that, and then I would have plus 1/2 times, what's the sine of theta? It's opposite over hypotenuse. And the cosine of theta is adjacent over hypotenuse. And so I end up with 1/2 arctan of x plus, square roots are going to cancel, an x on top, a 2, and a 1 plus x squared on the bottom, plus my c. Example 5 in the book is another tangent triangle problem, but their goal here is to show you 3 different methods, and they also use the hyperbolics for 2 different other solutions. We're not going to bother with that one because it's another tangent, and I don't really want to delve into the hyperbolics that much. So let's go ahead and look at example 6. A secant substitution. This is one we haven't done yet. So 1 to 4. Oh, look at this mess. Okay, it doesn't look like it's a secant. It's supposed to be a secant substitution, but we're going to do completing the square on the numerator, and it will lend itself to being one of those. So I'm going to take that x squared plus 4x minus 5, and I'm going to move the 5 down. Half of 4 is 2, 2 squared is 4, add 4, subtract 4. The first 3 terms factor to x plus 2 squared. The last 2 terms are minus 9. So this turns into the square root of x plus 2 squared minus 9 over x plus 2. So it looks to me that the u substitution should be x plus 2, which means du is dx, which turns this into u squared minus 9 over u. Now, changing out those variables, when x is 4, u is going to be 6, so there's a 6. When x is 1, u is going to be 3, so that's a 3. Oh, square root sign. Okay, so this looks like it should be a secant. So if I make my little triangle, we were doing the secant triangle, and the secant triangle says that you put your u here, in our case our x, and our a here, which would be 3, and this is the square root of u squared minus 9. So that's what I'm dealing with. So I'm going to say that I'm going to make a new substitution, and you want to use something besides a u, you can. Sometimes they use w's. Our book keeps using u, but okay. I'm going to use w. It's going to be, no, I have to use u because of my triangle. Three secant of theta, and so du is 3 secant of theta tangent of theta. So this turns into here's my little weird substitution again. Working with the numerator, I have 3 secant of theta squared minus 9 over 3 secant of theta. And so that gives me a 9 secant squared theta minus 1. That gives me a 3 secant squared minus 1 is tangent squared. And the square root of that, yes, is tangent. And then on the bottom I have a 3 secant. Okay, so back over here, I have a 3 tangent over a 3 secant for that mess, and then du is 3 secant tangent d theta. Oh, and here we go again. Got to change these out. So when my old u was 6, my new u is going to be 3 secant of 6. When u is 3, theta would have to be 0, because the secant of theta would be equal to 1 only at 0. And when u is 6, theta would have to be pi over 3, because 6 dividing by 3, that's a half. The secant is a half at pi over 3. So this becomes pi over 3, and this becomes 0. Excuse me, 6 divided by 3 is 2. The secant is 2 when the cosine is a half, and that happens at pi over 3. So now, if I clean this nonsense up again, we have a secant that cancels, We have 3's that cancel. We have a 3 on the outside and a tangent squared of theta, which we then turn into secant squared of theta minus 1, because the integral of the secant is the tangent, and the integral of negative 1 is negative theta. Now we don't have to go back to our triangle because we kept changing our variables as we went. And so I have a 3 tangent of pi over 3 minus pi over 3, subtract the tangent at 0 minus 0. The tangent of pi over 3 is square root of 3. So I get 3 times the square root of 3 minus pi over 3. Tangent of 0 is 0, so I get 3 to the square root of 3 minus pi. And this completes section 8.